All right, we're going to solve a problem here that involves a couple of runners. We have running Pat and Kim. And Pat runs at a rate of 8 miles per hour, and Kim runs at a rate of 6 miles per hour. And they're in a race. It's a long race. And Pat finishes 25 minutes earlier. And the question is, how long is the race? All right. So what we're going to do here is we're going to set up a table, and we're going to kind of analyze what's going on here. See if we can't figure out how long this race is. It'll be kind of a guess and check approach. However, before I set up this table, I want to point something out here. The way these rates are set up, 6 miles per hour and 8 miles per hour, right? If Pat runs at 8 miles per hour and Kim runs at 6 miles per hour, then that means she runs 8 miles in 1 hour and Kim runs 6 miles in 1 hour. And so if I have, say, for example, a table that was time and distance for Pat and Kim at, I'll say 0. They're all at 0. And after 1 hour, Pat has gone 8 miles and Kim has gone 6. And after 2 hours, Pat has gone, say, 16 miles and Kim has gone 12. And this table works pretty good if I'm looking at their gap in time. Or, I mean, sorry, in miles, right? The difference here, the difference of the gap, right? There's no difference when they start. There's a 2 mile difference, and then there is a 4 mile difference, okay? So the way their speeds are set up now, if I start making a table just the way they are, I'll be able to look at the difference in their miles. How far apart are they mile-wise at any given time? But I'm not really interested in how far apart they are mile-wise at a given time. I'm trying to figure out at what mile are they a certain number of minutes apart. So I'm looking at the gap in their times per mile. So that I need a time per mile kind of rate here. Well, it's pretty simple, because I can say that Pat at 8 miles per hour and Kim at 6 miles per hour, and I can write those rates out as fractions. I'm just going to flip them upside down and make it 1 hour per 8 miles. And over here, I'll make it 1 hour per 6 miles. And by the way, our gap, our time gap here is measured in minutes. So I don't really want our time and our rates measured in hours. I want them measured in minutes, but that's pretty easy because 1 hour is 60 minutes. So that'll be 60 minutes per 8 miles. And over here, that'll be 60 minutes per 6 miles. And let's simplify that if we can. It's like the most weird way of setting this up. 60 divided by 8 is, let's see, that's it's 30 over 4. That's 15 over 2. 15 minutes per 2 miles, which really is 15 halves minutes per mile. So 15 halves minutes per mile. And 15 halves, you turn it into decimals, like 7.5. So 7.5 minutes per mile. But I want to leave it as a fraction for now. 60 minutes and 6, that's 60 divided by 6 is 10 minutes per mile. Now I'm going to build a table where I'm going to look at how far apart they are time-wise at any given mile. Okay. So over here we're going to have time for Pat and Kim, and we're going to have distance. Oops, there we go. Right. Time for Pat and Kim and distance. So say at 1 mile, Pat at 15 halves minutes per mile has been running for 15 halves minutes. And Kim at 10 minutes per mile has been running for 10 minutes. I'm going to put minutes here as a label, and distance I'll put miles. Okay. And the difference is, let's see, 15 halves and 10. Well, I'll tell you what. I don't even really care what the distance is, the differences between them now, because here's why. I'm looking for a difference of 25 minutes. And I know that 10 minus 15 halves is not going to be 25 minutes. But it is actually 2.5 minutes. All right. That's easy enough. Okay, so let's do 2 miles. All right, so at 2 miles, 15 halves times 2. All right, we're doubling the distance, so it doubles the time. That's 30 halves, and 30 halves is really 15. And Kim has doubling her time, gives us 20. And the difference between 15 and 20 is 5. Right? And notice here, we doubled our distance, doubled everyone's times, and the difference doubles too. So let's see. Instead of just continuing, I was looking for a, let's do a couple more rows. Okay. So let's double this. Let's do 4. Let's double it again. So that would, if the distance doubles from 2 to 4, then we're going to double the time, be 30 minutes here. And 40 minutes for Kim with a difference of 10. Difference doubles again. Let's double it one more time. 8. So if we're doubling the miles, we're doubling the time it takes to run. So 60 for Pat. 40 times 2 is 80 for Kim. And the difference, 60 minus 80 is 20. Again, the difference also doubles. We're getting really close to that 25 minute. In fact, notice 5 minutes and 20 minutes. So it took them 2 miles to be separated by 5 minutes, and at 8 miles they're separated by 20 minutes. So at 10, 8 plus 2, right? So let's see, 10 times 15 halves is 150 halves, that's 75. And 10 times 10 is 100 minutes. And the difference is 25. Okay. All right, so notice, if you're doing a similar problem to this, say, that the steps were, we took their original times and we, instead of 8 miles per hour and 6 miles per hour, we changed those into hours per mile because that was better for our table. And then, of course, hours per mile, we really want minutes per mile, so we just replaced hours per mile with 60 minutes per mile, which then just kind of simplified. Then we can set up a table. We say, well, 1 mile, Pat goes so many minutes per 1 mile. Kim goes so many minutes per 1 mile. And then the difference between them is whatever the difference is between them. And then we just tried going down the table, and we could have just gone 2, 3, 4, 5, 6. But I was pretty sure at 2.5 we didn't have to quite go that slow. So I was kind of moving a little bit faster through the table. And eventually we got to 10 miles. So at 15 halves minutes per mile, that gives us 75 minutes. And at 10 minutes per mile, it gives us 100 minutes, which is the difference of 25 that we were looking for. So the race is 10 miles long. All right.